everyone, in this video we'll learn about rectification of a curve. Rectification of a curve means measuring the length of curve between 2 points using integration. So this is a curve and these are the end points of the curve A and B, and we are going to just find out the length of this curve from A to B. So we have few formulae related to this. So these are the formulae of rectification of a curve, or you can say length of a curve, which is also called as arc length, which we are going to denote by capital S. So these are the formulae related to the Cartesian curves. That means we have the curve in the form of either x or y. So suppose our curve is a function of x, that means y as a function of x, then the arc length s is equals to integration x1 to x2 square root of 1 plus dy dx the whole square dx. If our curve is a function of y, that is x is a function of y, then arc length s is equals to integration y1 to y2 square root of 1 plus dx dy the whole square dy. Obviously, here in the first case, we have a function of x. So we are going to derivate that function with respect to x. Hence, we will integrate the function also with respect to x. And of course, then we will write down the limits of x from x1 to x2. Similarly, whenever we have a curve as a function of y, then we will take a derivative of that function with respect to y. Obviously, we will integrate that function with respect to y, and of course, we will write down the limits of y from y1 to y2. Let us see some problems based on this type. So these are the simple problems where we have given a curve and also the limits in the problem itself. So prove that the length of the arc of a curve y is equals to log of e raised to x minus 1 upon e raised to x plus 1 from x equal to 1 and x equal to 2 is log of e plus 1 upon e. So let us try to prove this. And let us try to find out the arc length of the curve. We have given y is equals to log of e raised to x minus 1 upon e raised to x plus 1. That means y is a function of x here. So obviously we will use a formula to find out arc length when y is a function of x. So arc length s is equals to integration square root of 1 plus dy by dx the whole square dx. Obviously, here we will write down then the limits of x from x1 to x2. So in this formula, we require dy dx. So we will first find out dy dx of the given functions. So we have function y is equals to log of e raised to x minus 1 upon e raised to x plus 1. Before taking a derivative of this, first we will apply the property of log, that is log of e raised to x minus 1 minus log of e raised to x plus 1. Now we can easily take a derivative of this. So dy dx is equals to 1 upon e raised to x minus 1. That is a derivative of log. But then we have to use chain rule. Derivative of e raised to x minus 1 is e raised to x. So we will write that. So into e raised to x. Or similarly here, log of e raised to x plus 1. Derivative of that is 1 upon e raised to x plus 1. And again a derivative of e raised to x plus 1 is e raised to x. Then this is equal to e raised to x. That is a common term which we can write down outside. And we will write 1 upon e raised to x minus 1 minus 1 upon e raised to x plus 1. Then this is equal to, let us solve this. This is e raised to x into e raised to x plus 1 minus e raised to x minus 1. Please put bracket here because outside we have minus sign. This is e raised to x minus 1 into e raised to x plus 1. We know the formula a minus b, a plus b is nothing but a square minus b square. So let us apply that over here, and this will turn out to be e raised to x plus 1 minus e raised to x plus 1. Obviously, e raised to x get cancelled out, and here in the denominator, a minus b, a plus b is nothing but a square minus b square, which will give us e raised to x square minus 1 square, which is 1. So we will get at the end the answer as e raised to x, here this is 1 plus 1 is 2 upon e raised to 2x minus 1. So this is the value of dy dx that we are getting. over here, but we require in the formula dy dx the whole square. So let us find out that also. So dy dx the whole square is equal to e raised to x square. So e raised to x square is nothing but e raised to 2x. 2 square is nothing but 4 divided by e raised to 2x minus 1 the whole square. We require in the formula 1 plus dy dx the whole square. So let us find out that also separately. So this is 1 plus 4 into e raised to 2x divided by e raised to 2x minus 1 the whole square. Let us cross multiply. We will get the answer as e raised to 2x minus 1 the whole square plus 4 e raised to 2x divided by e raised to 2x minus 1 the whole square. Then obviously we are going to solve this and we will get it as we know the formula of a minus b square. So we can apply that here so that we will get e raised to 2x square, which is nothing but e raised to 4x minus 2 times e raised to 2x plus 1 plus 4 times e raised to 2x divided by e raised to 2x minus 1 the whole square. This is equal to e raised to 4x minus, this is nothing but plus 2 e raised to 2x plus 1 divided by e raised to 2x minus 1 the whole square. Now if you closely look at this equation which is there in the numerator, that is nothing but e raised to 2x plus 1 the whole square. You can see that this e raised to 4x you can write down as e raised to 2x the whole square. This is 2 e raised to 2x. This is plus 1 divided by e raised to 2x minus 1 the whole square. So this is nothing but e raised to 2x plus 1 the whole square upon e raised to 2x minus 1 the whole square. So this is the value of 1 plus dy dx the whole square that we are getting. And in the formula, we required a square root of 1 plus dy dx the whole square. That is equal to square root of e raised to 2x plus 1 the whole square divided by e raised to 2x minus 1 the whole square, which will give you e raised to 2x plus 1 upon e raised to 2x minus 1. And we are going to integrate this. So let us use a formula now of arc length, that is S is equals to integration x1 to x2 square root of 1 plus dy dx the whole square into dx. So this is equals to integration of square root of 1 plus dy dx the whole square is nothing but e raised to 2x plus 1 upon e raised to 2x minus 1 dx. And we need to find out here the arc length of y equals to log of e raised to x minus 1 upon e raised to x plus 1 from x equals to 1 and x equals to 2. So obviously limits will vary from 1 to 2. Now let us find out the integration of this. It is easy to find out if we use a little trick here, and that is we can multiply and divide by e raised to minus x here so that we will get a very nice result. Let us check that. This is e raised to 2x minus 1 dx. So let us multiply throughout by this e raised to minus x in the numerator as well as in the denominator so that we will get the value as e raised to x plus e raised to minus x divided by e raised to x minus e raised to minus x, and we will have here dx. Now you can see that the derivative of e raised to x minus e raised to minus x is nothing but e raised to x minus of e raised to minus x into minus 1. So that means e raised to x plus e raised to minus x. So derivative of the denominator is present in the numerator. We know the formula of integration f dash x upon f of x dx, that is exactly equals to log of fx plus c. So we can apply this formula in order to solve this. So let us see what we will get at the end. So this is equals to the integration of this function will turn out to be log of e raised to x minus e raised to minus x. That is nothing but the denominator. We have limits here. So let us substitute the limits 1 to 2. After substituting the limits, we will get the value as log of e raised to 2 minus e raised to minus 2 minus log of e to the power 1 minus e to the power minus 1. We can apply the property of log so that we will get e square minus 1 upon e square upon e minus 1 by e. So here in the numerator, we can apply a formula of a square minus b square, which will give us log of e minus 1 by e into e plus 1 by e, and in the denominator we already have e minus 1 by e. So this e minus 1 by e get cancelled out and we will get the final answer as log of e plus 1 by e, and this is nothing but the arc length of the given curve. Now let us see another example. Show that the length of the arc of the curve x is equals to y cube by 3 plus 1 upon 4y from y equal to 1 to y equal to 2. In this problem, we have given x as a function of y and limits of y are also given, so no need to draw a graph. So let us use a formula here. Clearly x as a function of y, hence we will use a formula to find out arc length as integration square root of 1 plus dx by dy the whole square dy. So obviously we need to write down here the limits of y from y1 to y2. Let's first find out in fact this square root of 1 plus dx by dy the whole square, and then we will substitute everything in this formula and we will find out the final answer. So given x is equals to y cube by 3 plus 1 upon 4y, which is same as y cube by 3 plus 1 by 4 y raised to minus 1. So now let us find out a derivative of this x with respect to y. So dx by dy is equals to, here 1 by 3 is constant, let us write it as it is. The derivative of y cube is 3y square. This 3 get cancelled out. Here again in this part 1 by 4 is constant, derivative of y raised to minus 1 is minus 1 y raised to minus 2. So we will get here this is equal to y square minus 1 by 4 y raised to minus 2 is nothing but 1 upon y square. So we will get dx by dy as y square minus 1 upon 4y square. Let us cross multiply this and find out the answer, which is 4 into y raised to 4 minus 1 upon 4y square. We required in the formula dx by dy the whole square. So let us find out a square of this. So the square will turn out to be dx by dy the whole square, which is equals to 4y raised to 4 minus 1 the whole square, and we will have in the denominator 4y square the whole square. Let us find out 1 plus dx by dy the whole square, which is equals to 1 plus 4 y raised to 4 minus 1 the whole square divided by 16 y raised to 4. And now this is equal to, by cross multiplication we will get 16 y raised to 4. Let us solve this 4 y raised to 4 minus 1 the whole square using the formula of a minus b the whole square. That will be 4 y raised to 4 the whole square minus 2 into 4 y raised to 4 and plus 1 divided by 16 y raised to 4. So this will give us the answer as 4 y raised to 4 the whole square plus 16 y raised to 4 minus 8 y raised to 4 plus 1 divided by 16 y raised to 4. This is nothing but 4 y raised to 4 the whole square plus 8 y raised to 4 plus 1 divided by, this is nothing but 4y square the whole square. If we closely look this numerator, we can understand that this is a perfect square of 4y raised to 4 plus 1 the whole square. See, 4y raised to 4 square plus 2 into 4 into y raised to 4, that is nothing but 8y raised to 4 plus 1. So this is 4y square the whole square. Let us find out a square root of this. So square root of 1 plus dx by dy the whole square is nothing but a square root of 4y raised to 4 plus 1 the whole square upon 4y square the whole square, which is nothing but 4y raised to 4 plus 1 upon 4y square. Then let us use a formula of arc length. S is equals to integration square root of 1 plus dx by dy the whole square dy with the limits from y1 to y2. Let us see y varies from where to where, which is given in the problem. So y varies from 1 to 2. So let us use that. So we will get s is equal to 1 to 2 square root of 1 plus dx by dy the whole square is nothing but 4y raised to 4 plus 1 divided by 4y square dy. We are just going to find out now the integration of this function. Before that, we will just separate the numerator. So we will get integration 1 to 2. This is 4y raised to 4 upon 4y square plus 1 upon 4y square dy. Here 4 get cancelled, 1y square get cancelled, and we will get in the numerator only y square, and here this is 1 by 4 y raised to minus 2 dy. Let us integrate it. This is a simple integration. So this is y cube by 3 plus 1 by 4 is constant. Integration of y raised to minus 2 is y raised to minus 2 plus 1, that is y raised to minus 1 upon minus 1 with the limits as 1 to 2. Now this is equal to y cube by 3 minus 1 by 4y with the limits 1 to 2. So this is nothing but 2 cube divided by 3 minus 1 by 4 into 2, that is 8. While substituting the lower limit, we have to give here minus sign inside the bracket. 1 cube is 1, so 1 by 3 minus 1 by 4. Complete the bracket and let us solve this simple thing. So this is 8 by 3 minus 1 by 8. This is minus 1 by 3. This is plus 1 by 4. And if I solve this, I'll get 7 by 3 minus 1 by 8 plus 1 by 4. So this is equal to 7 by 3 plus 1 by 8. And if I solve this, I'll get the final answer as 56 plus 3, that is 59 by 24. Thank you.